Let's be honest, we're drowning in plastic. I mean, it's everywhere, in our oceans, our food, and it's all made from fossil fuels. But what if there was another way? What if we could make plastic from plants, and when we were done with it, it would just disappear? That's the big promise of bioplastics. But the real question is it a promise that can actually be kept? So, really, could we just grow our way out of this massive plastic crisis? On the surface, it sounds like a perfect, elegant solution. But as we're about to see, the reality is, well, it's a lot more complicated. You've definitely seen these before. Maybe you even had your coffee in one this morning. It's a clear cup that looks and feels exactly like regular plastic, but this one's different. It's made from something called polylactic acid, or PLA, which comes from plant starches, usually corn. You could say it's the poster child for the whole bioplastic revolution. Okay, so here's our game plan. First, we're going to decode what bioplastic even means. Then, we'll follow its journey from a plant to a finished product, weigh the real-world pros and cons, and finally, we'll ask the big question, does it really do a disappearing act? All right, let's start with the basics, because a huge part of the confusion around bioplastics comes down to the word itself. It's kind of this catch-all term for a whole bunch of different materials, and honestly, not all of them are what you might think. So to really get this, we have to zoom way in, down to the molecular level, to something called a biopolymer. It sounds complicated, but it's not. These are just the big chain-like molecules that living things create naturally. Think proteins or the starch you'd find in a potato. They're basically nature's own building blocks. Now, if you only remember one thing from this, make it this slide. Bio-based and biodegradable are not the same thing. It's super important. Bio-based is all about the beginning of its life, what it's made from. Biodegradable is about the end of its life, whether it can break down. And here's the twist. A plastic can be one, or the other, or both, or neither. And this, right here, is the heart of the problem. You can have a plastic bottle that's made mostly from fossil fuels, isn't biodegradable at all, and yet it can still be marketed under that nice, green-sounding umbrella of bioplastic. Kind of misleading, right? So, how in the world do you get from a cornfield to a coffee cup? The process is actually a pretty fascinating piece of chemistry, and it's surprisingly similar to the oil industry we're all familiar with. It all happens in what's called a biorefinery. The easiest way to think about it is like this. You know how a traditional refinery takes crude oil and turns it into fuel and chemicals? Well, a biorefinery does the exact same thing, but its starting material is biomass, things like plants, grass, and agricultural waste. And one of its main products? Bioplastics. Okay, let's go back to our PLA cup. The process has 4 main steps. First, tiny microbes ferment plant sugars, creating lactic acid. Yep, the same stuff that makes your muscles sore after a workout. Second, that acid gets converted into a ring-shaped molecule. Third comes polymerization, where those rings are opened up and linked together into super long chains, creating the plastic. And finally, those long chains get chopped up into little pellets, which are ready to be melted down and molded into pretty much anything. So, making plastic from plants sounds like a clear win, a total no-brainer. But in the real world, there are no perfect solutions. There are only trade-offs. And bioplastics, well, they are no exception. Let's take a look at the balance sheet here. On the plus side, you're obviously using less fossil fuel, and since plants absorb CO2 as they grow, the whole process has the potential to be carbon neutral. That's huge. But on the minus side, growing crops for plastic means you're not growing food on that land. Plus, farming itself uses a ton of resources like water and fertilizer. And the biggest catch, as we're about to see, is what on earth you do with them when you're done. And that whole land use debate, it is a really big one. I mean, think about this. To replace all of the European Union's conventional plastic with bio-based versions, you'd have to use about 6% of its total farmland. That is a massive trade-off, and it brings up some really tough questions about our global priorities. Should we use land for fuel, food, or packaging? And that brings us to the final and maybe the most important question of all. Do these plastics actually disappear? This is where that shiny marketing promise meets the messy, complicated reality of waste management. So to really get to the bottom of this, we need a better word than just biodegradable. I mean, a fallen tree is biodegradable, but that can take decades. The word that really matters is compostable. It's a regulated term that means a material can break down into natural elements, but, and this is key, only in a specific compost environment and within a set amount of time.
So, you know what? Let's put this to the test. The source material for this explainer documented a simple little experiment to see what really happens. They just put a few different plastic products into a regular backyard compost bin and waited for 2 months.
Okay, first up, our control case. A normal styrofoam ball. After 2 months, yep, just as you'd expect, it is completely unchanged. No surprise there. Next, a compostable bio bag made from starch. Now, after 2 months, it has started to break down. You can see it's brittle, it's falling apart. But has it disappeared? Not even close. It's just fragmented into all these smaller pieces, which you could argue might even be worse. And now for the main event, our PLA cup made from corn, after 2 months sitting in a home compost bin. It's completely unchanged. It looks exactly the same as the day it went in. Visually, mechanically, absolutely nothing has happened. So what on earth went wrong? Why didn't it disappear like it's supposed to? Well, the crucial takeaway is this. Most of these common bioplastics, like PLA, are only compostable under very specific industrial conditions. They need sustained high heat. We're talking over 55 degrees Celsius, that a backyard compost pile just can't reach. So if you throw that PLA cup in a landfill or it ends up in the ocean, it's going to stick around for a very, very long time, acting a lot like regular plastic. And even worse, if you toss it in your recycling bin, it can actually contaminate the entire batch. Look, bioplastics are a really fascinating innovation. They push us to think differently about where our stuff comes from, and they might play a role in the solution. But they are not a magic bullet. They don't give us a free pass to keep our current habits without any consequences. Ultimately, what they really show us is that the biggest challenge isn't just about inventing a better material. It's about rethinking the whole idea of a throwaway culture in the first place.